welcome to everyone. Today we are going to discussing about another topic on computer network, which is resource reservation. So, in the previous sessions, we are discussing about the token bucket algorithm as well as leaky bucket algorithm. So, those are depending upon the information is transmitted in the frame structure as well as the token structure. So, same way, here while information is transmitted, we have to follow some kind of reservation mechanism that we calling as circuit switching as well as we calling as a packet switching. So, what is resource reservation? Resource reservation, which is nothing but we have to declare the specific route for each and every flow. We have to understand, we have to think about the specific route for the flow is known. That should be become possible to reserve the value, and along this one we have to make sure that the needed capacity which is available. So here we have to the needed capacity of the availability of reservation or the resource availability to check the situation. There are three kind of resource potential. We can understand that one. First one is the bandwidth, second is buffer space, next one is CPU cycle. So in the resource reservation, we have to store the parameter value, we have to reserve the mechanism value, we have to reserve the resources value, we have to potentially understand the values, that is bandwidth, buffer space as well as CPU cycle. So here while understand the resource reservation, first we have to understand the admission control policy. So what is this admission control policy? In the admission control, which refers to the mechanism that used by a router, or else if it is control any kind of routing mechanism, we have to control the admission policies. So admission mechanism by a router, or it switch or it adapt the network policy, it has to accept or reject, or else it able to switch the network policy values only. So that kind of flow based upon the predefined parameters are there, that we calling as a flow specification. So admission control, which means we have to refer the mechanism that is used by the router, or else that router it may take the decision or it may acting as a switch to accept or a switch to reject the mechanism based upon the flow or define the parameters of each and every flow specification. So if before the router accept the flow, we have to understand the processing structure, and if it check the flow value, check the flow specification value, we have to understand the capacity, and we have to use previous commitments to other flow can able to handle the new flow. So before we able to accept the mechanism, before we able to routing information transmit or the processing the flow value, we have to understand the what kind of specifications are there and what is the requirement of specification, that capacity understand that one, and this must be understand the previous commitment to flow, we can handle the new flow mechanism. So here discussing about the circuit switching. So in the circuit switching, the name itself is there is kind of circuit switching policies. So circuit switching in the sense, for example, you have terminal 1 is there, terminal 2 is there, terminal 3 is there. So all the links or all the switches are connected with switch 3, and similarly switch 2. Similarly, n number of switches are present until reaching the terminal 4, 5 and 6. So here what happened? Some kind of circuit switchings are there, some kind of link switchings are there, and some kind of dedicated connections are there. So that we calling as a circuit switching. For example, in the chapter 1 we discussing about this public switching telephone network mechanism. So where we are having as a base station, we have that one, we having as a main station, we having as a and the station, main station, and the main station and the nearby local towers. So these kind of policies and these kind of switching mechanism, we are using that one in the public switching telephone network. We having as a base station, we having as a main station. Similarly here also we have to follow the terminal 1 value, which is dedicated connections to switch 1, and similarly the link to the terminal 2 is linkage to switch 3. We have to understand this linkage parameter value, then that should be linked to the another switching, that should be processed to the terminal 4. For example, terminal 1 is my source, terminal 4 is my destination. So we have to follow the one can dedicated connection to a nearby switch hub, that should be linked to the next hub to the destination policies. So that we calling as a circuit switching. But what is a circuit switching? There are circuit switching having three phases are there. One is connection establishment, data transfer and connection released. So what is connection establishment? So in the circuit switching, so first we have to understand the connection establishment between the two networks. This is network 1, this is a network 2. So here we have to establish the information transmission from this network 1 to network 2. We have to establish what kind of proper connections. Once the connection is established, then we can able to transfer the information, which means either transmitter, or else receive the information from network 1 to network 2, which is vice versa. After successfully received or transmitted, the connection is released. For example, in the 1980s or in the later 1990s, where is the landline communication? How it works? So when we dial the numbers, which means the connection is established between the called person to the called person value. Once based upon dialing number, the connection is established, we discuss something else, the information is transmitted. After successful that one, we hang up the phone, which means the connection is released. So that kind of switching should be happens, that we calling as a circuit switching mechanism. So in the circuit switching mechanism, each data unit know the entire path address which is provided by the source. So here each data unit has to maintain the network policies, network path address value which is provided by the source. So in this circuit switching, data processed a source system only, not a destination. It processes only the source system. So here the resource reservation is there. That is a feature of the circuit switching, because the path is fixed for the data transmission, because here the fixed kind of transmission structure is there, because generally we will go for this LRA kind of communication. So fixed path information is there, that path only the information is transmitted or information is received for the prescribed path. That is called as a fixed path of data transmission. Here there is no chance of the store and forward techniques. And the next one is the packet switching. What is packet switching? The packet switching, here terminal 1 is there. Terminal 1 is the information is transmitted to the next terminal. Terminal 1 is information transmitted to the next hub switch value. So here n number of packets are transmitted. Here what happened? N number of packets are transmitted from terminal 1 to switch 1, and switch 1 is forward to the switch 4 value, or else maybe switch 3 value. Here what happened? Packet 3, 4 is there, similarly packet 1 and 2. So here what happened? Splitting kind of mechanism is there. For example, and transmitted for 4 packets are there. For terminal 1 to terminal 2 or switch 1, we have transmitted 4 packets are there. So out of these 4 packets, 2 packets are switching into switch 3 and other 2 packets switching into switch 4. And similarly switch 4 to switch 5. So again here what happened? Again you are able to merge that one. So merge to packet 1 to packet 3, 4. So that kind of packet switching, the name itself is the switching kind of mechanism. Packet should be switching, it should be splitting and transmitted to the next packet. So that kind of mechanism we are calling as a packet switching mechanism. So in the packet switching mechanism, so how it works? So packet switching is generally, so data is directly transferred that takes place, because the data should be transmitted from source destination. Directly data transfer takes place. If the packet switching, each and every data just know about the final destination address, internet path is decided by the routers. So for example, I am transferring information from A to F, right? So between this value, we having as a B, we having a C, we having as a D value, and we having as E value. So this path is decided by the routers. Our main motivation is information is transferred from A to F only, right? So this path is taken a decision which path shortest path, and what kind of path you choose, that one that decided by the routers. And so previously what happened in circuit switching, we having as a fixed kind of routers or the fixed kind of connection path is there, but here we having as a various path is there that decided by the routers. The internal path is decided by the routers, but in the previous one there should be prescribed a fixed path. So in the packet switching, data is processed all intermediate node including the source system. So data is transferred from the process all the intermediate node, that should be fixed one, previously the fixed one, but here there should be a variable one. Data is processed to the intermediate node that including the source system as well. And here there is no resource reservation is required, because here based upon the bandwidth sharing among to the user, there is no chance of this resource reservation, and it is a store and forward mechanism. So for example, in the circuit switching mechanism, the best example is landline communication, but we go for this a mobile communication, we go for this one. The packet switching, the best example is a mobile communication. Mobile communication, what happened? Based upon the towers, we are going to switch the network values. The network will choose the path values and information transmitted the channel values only. So that is the reason it got a fixed value. It is decided by the router. So that should be intermediate node values only, and that should depend upon the bandwidth. For example, if 10 channels are there, the limited band channels, 10 channels are there, we have to, if the channel 1 is idle, we have to use that channel. The channel is free state, we have to choose that channel, or else choose channel 2. So whatever channel is available, we jump on that one, we have to choose that channel. But here what happened? Prescribed path is established, so the information is transmitted through that path only, or else received from that path only. So at the same time, there is no chance of the storing forward, but here we have to shift the channels based upon the mechanism value. So there is no reservation is required based upon bandwidth services. So it has to maintain the store and forward technique is possible. So in this session, we are discussed about the three important parameters, which is resource reservation, circuit switching, and packet switching. So the resource reservation, how we are able to reserve the resource value while information is transmitted from source to destination path mechanism, as well as if the resources are ideal state only, we go for this reserve the mechanism. If the resources are busy, right, even though we reserve the mechanism, we have to future prospective. After successful completion of this mechanism, then we go for initiate the transmission process. That kind of resource reservation is possible, that we calling as a resource reservation mechanism. In the next one, circuit switching mechanism. The circuit switching mechanism, which means similarly calling as linear communication, which is a wide kind of communication. A fixed amount of path is prescribed here, but in the packet switching, there is no fixed path is there. Based upon the bandwidth mechanism, we have to choose that one, that we calling as a packet switching mechanism. So the comparison between circuit switching and packet switching, most of the scenarios in the real-time world application, we go for this packet switching mechanism. The information is stated by packet to by packet, or one-to-one communication, one-to-many communications, or wireless communication. So this kind of architecture we are going to implement it, because there is no amount of fixed amount of path is fixed, that one, because in the we have to change the mechanism. We are not feasible to all the time to maintain the fixed path value. So we have to variable kind of path, we fix that one. We have to choose a variable kind of path architecture that is possible wireless communication, that is choosing the packet switching mechanism. So next session we are going to discussing about is IPv4 and IPv6. So what is IPv4 and what is IPv6, which we are calling as Internet Protocol version 4, Internet Protocol version 6. So all the things is purely dependent while we are discussing about the transport layer in the network layer. So this purely discussing about purely based upon the IP address mechanism values only, which we are calling as a routing algorithm or routing mechanism, which we are calling as a Internet Protocol architecture values only. So they are discussing about this different kinds of frame structure, different kind of packet architectures. So all kind of has a kind of source address, we have a destination address, we having as a fixed values, we having as a variable bandwidth value. So all these things that should be must be depending upon what kind of internet path you choose that one and what kind of IP address we have that one. So that is the importance of this IP protocol, which we are calling as Internet Protocol. So in the next topic, in the next session, we are discussing about the IPv6 version 4 value and IPv6 version 6 value. So in this session, in the next session, we are discussing about what kind of framing architecture is there and what is the usage of this IPv4 and where we are using this IPv4 in the real-time application as well, and compared to the IPv6, which is helpful for us, because all the time we are not using this IPv4 and all the time we are not using this IPv6, because that should be depending upon the cost perspective, the bandwidth perspective, all the things that comes to the picture. So while we understand the practical scenario which is suitable for us, which is IPv4 or IPv6 version, so that we discussed in the session, in the upcoming sessions. Thank you.